Hey there, fellow builders and makers. Today we're diving into the fascinating world of investment casting. Ever wonder how those intricate metal parts in airplanes, cars, or even medical devices are made? Investment casting, also known as lost wax casting, is the secret behind many of these engineering marvels. This process has been around for centuries, with roots dating back to ancient civilizations, but don't let its age fool you. Investment casting is far from outdated. In fact, it's more relevant than ever thanks to constant advancements in materials and technology. So what exactly is investment casting? It's a precision casting process that allows us to create incredibly detailed metal parts with complex shapes and smooth finishes. Think of it as creating a detailed sculpture, then making a mold to reproduce it in metal. From tiny jewelry pieces to massive turbine blades, investment casting plays a vital role in various industries. It's all about achieving accuracy, complexity, and high-quality results. Let's break down the steps and explore this amazing process together. Our journey begins with the creation of a wax replica, the heart of investment casting. Think of it as making a temporary, highly detailed model of the final metal part. First, we need a pattern. This is often created using injection molding, where molten wax is injected into a metal die. The die acts like a cookie cutter, forming the wax into the desired shape. The beauty of wax is its versatility. We can create intricate designs, sharp edges, and smooth curves with incredible precision. And if we need multiple identical parts, no problem, we can create multiple wax patterns from the same die. Modern technology has brought exciting advancements to this stage too. 3D printing, for example, is revolutionizing pattern creation, allowing for even greater design flexibility and faster prototyping. With our wax replica ready, it's time to build a protective shell around it. This is where things get messy, but in the best way possible. The wax pattern is dipped into a ceramic slurry, a mixture of finely ground ceramic particles and a binder. This slurry coats the pattern, creating a thin, uniform layer. Next, the coated pattern is dusted with a refractory sand, which sticks to the wet slurry. This dipping and dusting process is repeated multiple times, building up a strong, multi-layered ceramic shell around the wax pattern. Think of it as creating a plaster cast, but with layers of high-tech ceramic instead. Advancements in ceramic materials are pushing the boundaries of this process even further. Newer materials offer improved mold strength, thermal stability, and the ability to reproduce even finer details. Now here's where the lost wax part comes into play. We need to remove the wax pattern, leaving behind a hollow ceramic shell ready for metal. The ceramic shell is carefully placed in a furnace, where it's heated to a specific temperature. As the temperature rises, the wax inside melts and flows out of the shell, leaving a void in its exact shape. But the journey isn't over yet. The shell undergoes further firing at extremely high temperatures, reaching over 1000 degrees Celsius. This high-temperature firing strengthens the ceramic, eliminating any residual wax and preparing it for the molten metal to come. Section 5. The molten heart, metal pouring and cooling. With our ceramic shell prepped and ready, it's time for the main event, pouring the molten metal. This is where the transformation from wax replica to metal part truly takes place. The preheated ceramic shell is carefully filled with molten metal. The choice of metal depends on the application, with common options including steel, aluminum, and even titanium. Gravity casting is the most common method, utilizing gravity to fill the mold. However, other techniques like vacuum casting are also employed to improve metal flow and reduce porosity. Once the pouring is complete, the metal is left to cool and solidify within the ceramic mold. Controlled cooling rates are crucial to minimize internal stresses and defects in the final casting. Section 6. Unveiling the masterpiece, shell removal and finishing, the moment of truth. With the metal solidified, it's time to remove the ceramic shell and reveal the casting within. This is usually done mechanically using hammers or vibratory equipment to break away the shell. Once the shell is removed, we're left with a near net-shaped casting, meaning it closely resembles the final product. However, some finishing touches are usually required. This might involve removing any remaining sprues or gates, which are channels that allow metal to flow into the mold. Additional finishing processes like grinding, polishing, or machining might be employed to achieve the desired dimensional accuracy and surface finish. Section 7. Advantages and limitations, a balancing act. Like any manufacturing process, investment casting has its pros and cons. Understanding these is crucial for choosing the right process for a specific application. On the plus side, investment casting offers exceptional accuracy and detail. We can create complex shapes with tight tolerances and smooth finishes, often requiring minimal post-casting machining. It's also incredibly versatile in terms of material selection. From basic metals to superalloys, we can cast a wide range of materials, making it suitable for demanding applications. However, investment casting can be time-consuming and expensive, especially for large production runs. The multi-step process and tooling costs can be significant, making it less suitable for simple, high-volume parts. Additionally, while investment casting excels at smaller parts, it faces limitations in size. Casting large components can be challenging and less cost-effective. Section 8. Advancements in investment casting, pushing the boundaries. Despite its long history, investment casting is far from stagnant. Advancements in materials, technology, and automation are constantly pushing its boundaries, making it even more precise, efficient, and sustainable. One exciting development is the use of three-dimensional printing to create wax patterns. This allows for complex geometries and faster prototyping, reducing lead times and design constraints. Advanced ceramic materials are also playing a crucial role. Newer ceramic slurries offer improved mold strength and stability, enabling thinner shells and even finer detail reproduction. Automation is another key driver of progress. Robotic dipping systems and automated shell handling streamline production, reduce labor costs, and ensure consistent quality. Section 9. Conclusion. A bright future for precision casting. As we've explored, investment casting is an intricate dance of art and engineering. It's a process that demands precision, patience, and a deep understanding of materials and their behavior. From ancient origins to modern advancements, investment casting has played a vital role in shaping our world. It allows us to create intricate metal parts that power our machines, enhance our lives, and push the boundaries of what's possible. As technology continues to evolve, we can expect even more exciting developments in the world of investment casting. New materials, advanced automation, and the integration of digital tools will further enhance its capabilities, making it an even more essential process for industries that demand precision and complexity. So the next time you marvel at a complex metal component, remember the fascinating journey it took from wax replica to finished product. Investment casting, with its rich history and bright future, will continue to shape the world around us, one intricate part at a time.